Hello, I hope you can hear me. I'm going to make a quick video on some division, mostly the long division because that's the harder one. Hang on, get used to these buttons again. Let's use drawing and we're going to use the color green, let's say. Okay, so the key is if you're dividing by a binomial or anything that's not a monomial, you need to do long division. So we're going to write this as a long division problem. And I'll try to be fast because I have a class here in a few minutes, but I think I can do this video real quick. So we're going to rewrite this as long division. Now real quick, if you have something like, let's say you had something like this. Let's say, I'm making this up, but what you would do, or x cubed, let's say, you would split, when you're dividing by a monomial, you don't do long division, okay? So if you're dividing by monomial, you want to set it up like this. And yes, this is going to have a lot of fractions because I made it up in a hurry. Whoops. So if you're dividing by any a monomial, you always split them up. And then you would cancel common factors. So this one is going to be a 5 upstairs and a 2x downstairs plus 3 and over an x squared, right? Over 2x squared. And then this one's a negative 2 upstairs and x cubed downstairs. So it looks a little weird, but that's how you approach this type of problem. If we're doing a polynomial that's divided by anything that's not a monomial, you need to do long division. So this can get pretty messy. So I'm going to try to use a lot of colors. But your first question, this is like long division back in the olden days, where you do first dividing and then multiplying. Then you're doing subtraction and then you're doing bring down and then you repeat. This is like dividing, let me find my eraser. This is like you dividing numbers without a calculator where you had to do long division. So the first thing is divide and then multiply and then subtract and then bring down. So we're going to start out and we're going to divide, just like if you had a 3 goes into 17,689, for example, the first question you ask is 3 goes into 1, never. 3 goes into 17, how many times, right? So you're dividing. So 3 goes into 17 5 times. So you put the result of that up top, just like you did in the olden days. So here we're going to actually divide the first into the first. So you're asking, x goes into 2x cubed how many times? And if you write it like this with a numerator and denominator, you can simplify it easier. So your first question is this one into this one, how many times? So x goes into 2x cubed how many times? And students struggle with this at first until I show them, hey, this is just, you could write this as like this. And you would cancel the common x's, and then you would have a 2x squared left over. So x goes into 2x cubed, 2x squared times. Now, what's next? So you did your dividing, and then what do? Back in the olden days, you would take that 5 times that 3, and you would multiply it, wouldn't you? So you would have a 15. Well, here, we're going to take the first one, we're going to multiply it too, but we're going to multiply it through. So we're going to say 2x squared times x is 2x cubed, and usually students with who use the arrows, who use the colored pencils, usually do better because it gets a little messy. So the one thing that's different about multiplying here, we just had the 5 times the 3 is the 15, but we need to multiply through. So you're going to multiply 2x squared times x, and then you're also going to multiply 2x squared times negative 2. So you get a negative 4x squared. Then, so we did this one. Now we're going to subtract. Now, back in the olden days, you said, hey, I'm going to subtract this, when you subtracted it, did you not draw the line and then change that sign to a minus technically? So then you had it 2. Well, subtracting for us, just say draw the line, and it rhymes a little bit, change the sign, change all the signs in the second row. So here we just had the 15, so we just had that one sign to change. Here we have 2 terms, and we're going to change that sign in each one. So I tell students always circle your new sign. So you had a positive 2x cubed, now you have a negative 2x cubed. Then you have a negative 4x squared, that becomes a positive, so I'm going to circle my new sign. So you draw your line and change each sign, done. Then you combine like terms, so you're still kind of subtracting, but you're combining like terms. 2x cubed minus 2x cubed is gone, so that first one always has to delete or eliminate, but it's not something you forced, it just happened. And then the second one is 4x squared plus 4x squared, because the new sign is plus, so you get 8x squared. Then what do? So we took care of subtraction, and then I kind of do the, like in some of the elementary places, you know, it says daddy, mommy, sister, brother, and that helps students remember. So sister was the subtracting, and then we bring down minus 19x, but you just bring down the next guy. So just like in the olden days, you brought down that 6, you didn't bring all of these down because all of a sudden people want to bring down that 4. Well, you're only going to bring down the next guy. And then what do you do after you bring down the next guy? You repeat. So we start over. So I'm going to start over in a different color so you can follow it easier, I hope. So we start over. What do? We divide. Okay, what do we divide? Well, here you ask 3 goes into 26 how many times, you know? 3 goes into 26 how many times? Well, we're going to ask the first one, x goes into 8x squared how many times? You see? This one into this one. So you always just divide the first one, but then you multiply it through to all of them. So what do we get? X goes into 8x squared how many times? And it's just an 8x. Just a second. So is it positive or negative? It's a plus 8x, right? X goes into 8x squared, 8x times. So what do you do with that? Now it's time for mommy. We're going to multiply through. 8x times x is 8x squared. 8x times negative 2 is negative 16x. So that was multiply. Now we're back to subtract. Subtract means draw the line, change each sign. This was a positive, now it's a negative. This was a negative, now it's a positive. This is where most of your mistakes happen, the signs. 8x squared minus 8x squared is gone. It has to, but we didn't force it. And then negative 19x plus 16x is negative 3x. So now you bring down that 4 plus 4. And then we're going to use another color. So we start over again. What do we want? Brown. So what's our next question? X goes into negative 3x how many times? So just a second, I'm going to get rid of those. My next question is x goes into negative 3x how many times? The x's cancel and you get a negative 3, right? So you put that up here. The result always goes to the top. What do we do with it? We distribute it back through. You see how this gets very messy, but if you have a system, you're not going to have a problem. Negative 3 times x, negative 3x, negative 3 times negative 2 is positive 6. So what's your signs? Negative times negative is positive. Now you say, I'm going to subtract. So you draw the line and change each sign. And you have negative 3x plus 3x is gone. 4 minus 6 is negative 2. This is your remainder. But in the olden days, you could just say r negative 2. You can't do this nowadays. So where here you would put remainder something. We're going to have to put the remainder up here. And what you always do is you put the remainder over the original denominator. The original denominator was x minus 2, if you can still find it in this mess. But there has to be a sign here. So be very careful that you put a sign. You need a sign, because I have students every semester that say, hey, the computer won't accept my answer and my answer is correct. Well, what they do accidentally, they put that sign up here. And then if they have a 3 right next to it, it's technically one term. But these are 2 terms. So that sign should go in the front. So this whole mess is your final answer. Okay, so hopefully that helped. I'm going to stop the recording if I can find my button.